In this video, we are speaking about some definitions. This green block represents a system. The system has one input u and one output y. Of course, these are time functions, so it's u of t and y of t, and there is a direct relationship between them, and it is represented by the letter s. This s is an operator. What is the operator? Operator is the input-output relationship. Now, S is a differential equation in this case. This S, I mean the system, can be linear or non-linear. The system is called linear if the representation, if the ordinary differential equation is linear. The system is not linear is the input-output relationship. In our case, the ordinary differential equation is not linear. We could see two linear examples before, the model of the vehicle. And we could see one non-linear model, the model of liquid level system. In the linear model, there is no non-linear functions. In the non-linear model, for example, in the water liquid level, there was the square root of the liquid levels in that case. So this is the difference between linear system and non-linear system. We have studied some electrotechnics. The Ohm's law is linear. We have studied some mechanics. The characteristic of the spring is also linear because the connection between the input-output is just a very simple multiplication. So for example, there is no x square or the function of I, and this function is non-linear. So let's see on the right the difference between the linear and the non-linear characteristics. The linear characteristic is just a straight line, and this straight line is crossing the origin. This is a linear characteristic between the input u and the output y. The other is not linear, so it's quite easy to see that. One part looks like x squared or something like that. So this function is not linear in this case. What is the superposition which I mentioned here? For linear systems and linear characteristics, the superposition is valid. For nonlinear systems, the superposition is not valid. What is the superposition? First, let us imagine two individual inputs, u1 and u2. The output for u1 is y1 and the output for u2 is y2. It can be obtained if we solve, for example, the ODE for u1 and u2. And now the question is, what is the output if we sum u1 and u2? The output will be y1 and y2. If it is valid, so the representation S is linear, we say that the superposition is valid and the system is linear. For example, let's see, this is u1 here, this is u2 here, and the output is y1 and y2. And now let's add u1 and u2. It will be here, for example. And the output is here, which is the sum of y1 and y2. So it's very easy to see it is valid. So it will be not valid for nonlinear system. Use another color to see that. For example, this will be u1 and u2. It's quite easy to see that y1 and y2 are 0. So the output of u1 plus u2 should be 0, but it is somewhere here. This is u1 and u2, but the output is not 0. So the superposition is not valid for nonlinear. The other two things are the time invariant system and the time varying system. The time invariant model is very simple. The coefficients are not changing with time. For example, f equal to kx in the spring model, the k is constant. It is not changing with time. So if we have a time invariant system, the model parameters are not changing with the time. It is not true for time varying systems because the coefficients of a time varying system are time dependent. Very nice example is the mass of an aircraft. The mass of an aircraft is decreasing due to the fuel consumptions of the traveler. It is decreasing. In our lectures, we are going to speak only about LTI systems, and the LTI means linear and time invariant systems. So this is the system set we are going to work with. I have to mention that LTI systems are the simplest models. Some videos before we have spoken about the formulation of the ordinary differential equations, and there we could see some nonlinear and linear ODEs, some invariant and time varying ODEs. So these two videos are connecting to each others because here we are speaking about the definitions of linear and nonlinear system, time invariant and time varying systems, and there in the other video we have spoken about the linear, nonlinear, time varying and time invariant ordinary differential equations. And now I have to repeat that if we speak about a system, inside a system there is the system model, and the system model is usually an ordinary differential equation for our questions.